We are doing accumulation of change. Basically what this is saying, let's go ahead and look at the problem first. A freight train leaves the station on a 10-hour trip. The graph below shows the train's velocity as a function of time. Let's remind ourselves that velocity is the same thing as speed. And notice right here we got miles per hour. That's speed, but in higher mathematics it would be called velocity. And that would be the same thing your car would have. We travel miles per hour. This is as a function of time in hours. How far does the train travel? And they're giving us in miles already. So basically the idea is that if we're at 1 hour here, that would be right here on the graph, it would be the accumulation of everything below that. So basically the idea is that it's all the space underneath this graph, curve, line set, whatever we want to call it. So the strategy goes is that we need to make this into triangles. So these are our options, triangles, rectangles, or trapezoids. Okay, and a trapezoid can be made into a rectangle, a set of rectangles and triangles, but it's just making your work harder if you don't do the trapezoid. You have more calculations that you have to do. So reminding ourselves what these trapezoid looks like, it would be something like this. So that's a trapezoid, and one of the sides could be flat. All right, so basically it's the area of a triangle, which is 1/2 base times height, and the base and height have to be perpendicular to each other. Rectangle, length times width, and a trapezoid is a plus b over 2 times h, where a and b are the bases. So I've already drawn one here. This, we can call this bottom one b, we can call this top one a, and then the height would be going from one base to the other, like how tall is it from one base to the other. All right, and that's the strategy that we're going to use here. So we have to, when we look at these graphs, they're not curves yet, so they're all straight lines, so they can be made up into triangles, rectangles, or trapezoids. So when we look at this one, it's real important to label these correctly because it's real easy to kind of get knocked off at the different numbers. So how can we make this into triangles, rectangles, and trapezoids? So the key is I can't just draw a line straight over to here because that's not a clear base that we know. We want to do this in such a way that we can see what the sides are for any of them, for the bases, so to speak. All right, so I'm going to go ahead and make this into a triangle right here. All right, so there's my perpendicular. This would be the base. This would be the height of that triangle. And let's see, then I'll go ahead and make this into a trapezoid. So this would be the base of the trapezoid, the second base of the trapezoid, and then this distance right here is the height of the trapezoid. All right, and then it looks like we have one more trapezoid here. So this last trapezoid, I'll go ahead and change my color. So this would be what I'm calling the A. This bottom would be what I'm calling the B, and then this would be the height. All right, and I'm going to go ahead and just change the colors so we don't get confused. I'll change this one to pink. All right, and then usually we'll label these. So triangles, I'll just call it like a triangle sign or a delta sign. We only got one triangle. It looks like we got two trapezoids. I'll call the trapezoids T1, and T2. So that's all the space inside of here. And then we just got to be careful about labeling everything, and then that'll be our answer. All right, so let's just kind of be careful about each one of these and go from there. All right, let's go ahead and start off. I got pink, so let's start off with pink. So this one right here, this B is equal to 1, 9 to 10. The height goes all the way up, so that would be 0 to 50. So that height is 50. All right, let's just double check. I don't want to make any mistakes. Check. So that's everything I need for that triangle. I'm just going to label everything right now. And then for this first trapezoid for T1, let's go ahead and give it the proper color. That would be A, B, and height. All right, so let's go ahead and just do A first. So that would be from this part to this part. So that is from 4 to 9. From 4 to 9 is 5 units. 1, 2, 3, 4, 5. So A is 5 on that one. This B right here, this base is from here to here. So that would be from 3 to 9. From 3 to 9 is 6. So that base is 6. And then our height from 40 to 50 is 10. So that's equal to 10. All right. And then let's go ahead and do the last in purple. The last trapezoid. This A right here is from here to here. And that would be from 1 to 9. So that A is equal to 8. Let's get the color to be the matching here. And then the bottom base is from 0 to 9. So that's equal to 9. And then the height here is equal to 0 to 40. 0 to 40 is 40. All right. And just as a note, if you're struggling with trapezoid, remember if there's some shape that you're not sure about, you can always look it up, and then that can kind of give you a better idea of what's going on here. Okay. Definitely you should do these by hand, not just type them in. All right. So let's go ahead and piece everything together and go from there. All right, now I'm going to go ahead and just use red. So I'm going to go ahead and find each piece and then go from there. Actually, I'll just go ahead and keep the colors. That's not too hard. All right, so the area of the triangle, so this is triangle, is going to be equal to 1/2, and I already got the formulas here. Always write your formulas out. 1/2 base, the base is 1. The height is 50. So that's going to be equal. Half of 50 is 25. All right. And we'll worry about our units later. It's not too big of a deal since they're giving us units. We would include them if we had to, and things would cancel. It'd be fine. All right. So there's our triangle. Check. Let's go ahead and do red. Triangle 1. Sorry, trapezoid 1. Trapezoid 1 is equal to A plus B. Don't clear screen. A plus B. So A is 5 plus B is 6 divided by 2 times height of 10. Okay. 2 goes into 10 5 times. We got the 5 plus 6. So just kind of doing things in pieces here. 5 plus 6 is 11, and 2 goes into 10 5 times. I get 55 here for triangle 1. And our purple triangle, triangle 2, is equal to A plus B over 2 times height. Keep reminding yourself of the formula. Try to memorize it. Always helps. A is 8 plus B is 9 divided by 2 times height of 40. Okay. 8 plus 9 is 17. 2 goes into 40 20 times. So just doing reducing and simplifying. 17 times 20. I don't want to do all this work and make a mistake with my arithmetic. 17 times 20, 340. 340. All right, so all of this now turns into the area of this triangle, or the accumulation of the change, is going to be delta plus trapezoid 1 plus trapezoid 2, which is going to be 25 plus 55 plus 340, which is equal to, so that's what, 70, 80, 340 plus 80, 420. All right, and that should calculate all the space underneath here. It looks like I've included everything. Let's see how we did. So the big thing here is just making sure that you label everything appropriately and you include it all. All right, and there we go. So all of them are going to be these kind of pieces. There was no rectangles here. We could have broken up one of the trapezoids into rectangles and triangles, but definitely easier just to deal with a trapezoid than rectangle triangle. So just as an example, I could have broken this one up into a rectangle here and a triangle here and added those two together. It would have been two more formulas, or one more additional formula I'd have to use. But if you forget the trapezoid formula, you can always make it into triangles and rectangles. All right, the rest of them should be very similar. Let's take a look at the next one. And yes, there you go. I would just make that into a oh, this one's straight trapezoid, so that's not too bad.